Chemistry is going on all around us all the time. So what evidence do we have that there are chemical reactions going on? Well, remember, chemistry is about change, the changes that matter undergoes. And remember, matter is everything that we can see and not see. So that means all these changes that are going on all around us are going on to matter, and those are all chemical reactions. So in this picture, when leaves are growing or when leaves turn from green to maybe yellowish, those are changes, and changes signal chemical reaction. Or this bike is a rusty metal bike. When a metal rusts, that's a change. That's a chemical reaction. Color changes are the most common that we'll see in upcoming reactions, like color changes that you might have in your lives are coloring your hair, bleaching, dyeing. That's a color change, and that's a chemical reaction. We've also seen in lab combustion reactions where things are burning, and that's a change, that's a chemical reaction. So these are just a few examples of the changes you see on the macroscopic scale every day. And so chemistry is going on around you every day. So we can see these physical changes, these color changes. Physical changes are what you can see with your five senses. But we cannot see the microscopic changes at the molecular level. So these are the chemical changes that we will get into to understand the chemistry of every day. Okay, so we're going to start into the details now of chemical reactions at the molecular level and go into predicting reactions when you're given chemical compounds that are reactants at the molecular level. You can't see those reactants. Color changes are the best example of a chemical reaction. This is a leaf turning colors in the fall, so from green to red, yellow, orange. It's not magic, it's a chemical reaction. For leaves, it's actually a series of reactions. Leaves turn yellow, red, and orange in the fall because there's less sunlight, and so the plants stop making a compound, chlorophyll. And chlorophyll is responsible for the green color of leaves, and so without the chlorophyll, the plants break down the chlorophyll, and so no green is present without it, and so it reverts to the colors that were present in the absence, which are the red, the orange, and the yellow. So those are the remaining pigments once the chlorophyll is broken down. So let's look at this chemical reaction which does produce a yellow compound. This yellow compound is lead 2 iodide. So let's look at this chemical reaction that starts with two clear solutions. So this is clear, that's clear, but mixing them together produced this yellow product. And so that wasn't there before. Anytime there's a color change, clear and clear makes yellow, color change means chemical reaction. So two colorless solutions are the two reactants, and the product includes this yellow product. Now this is called a precipitate when there's a product that is a solid that wasn't there before and is there now. And this is a precipitate that you can see starts to fall to the bottom. And just like rain is called precipitation, it falls from the sky, this is a precipitate. It's a solid formed that falls to the bottom of the test tube. Eventually all this yellow will settle out. See metal rusting. This is an example of a redox reaction. So we talked about redox reactions in the last chapter, and this is when you have something oxidized and something else is reduced. The oxidation reaction, one substance loses electrons, and the reduction reaction, another substance gains electrons. All that goes on together in a single redox reaction. And in the process, electrons are transferred. So one substance loses electrons, the other substance gains electrons, oxidation, reduction, all going on in a single reaction here. Usually the substances that are losing and gaining electrons are metals, and we talked about batteries, how there are metals inside of batteries. These are all the household alkaline batteries, and this is also what happens in rust. So a rusty lock here is a redox reaction where one metal is losing electrons. This is the iron solid becoming an iron ion. this is losing electrons, and the oxygen gas that comes from the air, this gains electrons when it goes into this ionic compound Fe2O3. So in the process of electrons lost by one substance and gained by another substance, there's a transfer of electrons, and that flow of electrons when they're separated, this allows for flowing through something like a voltmeter or through an electronic that you're trying to power, and that is electrical energy, which is the movement of the ions. And so we'll start with the single replacement reactions that produce electrical energy from a battery, and this we'll see in lab as well.